So a very common electrical issue that can come up when you're doing other projects, not just electrical, is when you come across a damaged wire. Now, maybe you nicked a wire in the wall while you were trying to hang a picture, or maybe you found some exposed wires from an old renovation. Well, damaged wires are not just an inconvenience. They can actually cause arcing, short circuits, or even fires if you ignore them. So in this video, I'm going to show you how I go about fixing those damaged wires in a home, and also point out some common mistakes that you need to avoid to keep you and your home safe. So let's go ahead and jump right in. All right, so for our first one, we're going to call this the old school method. So this is very, very common. Maybe you're putting this hole in the wall because you want to put some anchors in, whatever the case may be. Super common for people to be using drills, and when they make that hole in the wall, they end up hitting a wire or even plumbing. But in this case, we're talking about fixing electrical wiring. So drywall is a pretty easy thing to fix. So the best way that we can go about figuring out if something did go wrong is we're going to need to cut a very small exploratory hole here in order to see if we did in fact hit something. But the first thing that we always want to do is make sure that we turn off the circuit breaker that supplies the power to whatever it is that we're about to start working on. So there are a few ways we can go about doing this. All of them require some sort of a saw blade. So since we think there might be something in behind here, of course, you want to be careful when using it to not cause further damage. Now you can use things like a drywall saw or a jab saw, but for me personally, I like to use a multi-tool like this one here. So what I'll do is I'll just make a very small square all around the drill hole that I made. And then once I've got that all cut out, I'll just remove that drywall and start my inspection. All right, so as you can see, as soon as we open this up, we can see this wiring in behind here, and we can also see a cut in that sheathing on the wiring. And just bring it in a little bit closer, you can see this cut up here on top. Now, one of the big issues with this happening and where it can cause a major issue is a lot of the wiring in homes now is Romex. And what you have is you have a cable that has a hot, a ground, and a neutral wire all in that one piece of sheathing. Well, the way that they have them put in there is your hot is on this edge here, your ground is between the neutral and the hot, and then your neutral is on the other side. So if we've got a hot wire that's right next to a ground wire, then you can see where there might be an issue. Best case scenario is it just starts tripping the circuit breaker and trying to alarm you, hey, something is wrong. So now we've confirmed that we did in fact damage our wiring, so now what do we do? Well, this hole wasn't cut for nothing. We're going to end up having to make this hole bigger for this particular method. And the reason for that is because the most common way that these are fixed is they need to now be in some sort of a contained junction box. We can't just have this exposed wire hanging out in the wall, and now that they are cut open, you do definitely need some sort of containment, but there are some rules that go along with this as well. So in order to do this, what you're going to need is some sort of an electrical box like this one here. Now this is a single gang box. So here would be a double gang box. You can see quite a bit larger. Well, the issue that can come up is if you then put your finger in the wall and you start pulling on that wiring and you don't feel that you've got a whole lot of slack there, there's not a whole lot of wire to work with. While a single gang box will work, you're gonna have a lot less wire in order to feed into this box. It's just a lot smaller, so it's gonna be hard to get the two ends into this box. Whereas if this is the case, using a double gang box, because it is so much wider, you're able to get more wiring into the box because it's going out towards the different sides of the wiring better, which is going to make your repair easier, and it's also going to make sure we're not putting too much strain on our connection points that we're going to make in a moment. So for me personally, since I do not have a whole lot of slack here, what I'm going to do is I'm going to cut a hole big enough for this double gang box. Alrighty, so now I've got a lot more room to work with. Where my cut is or where the damage is, I start there and make a cut on it. Now I've got two separate wires. Then I usually bend them in towards the room. Then I will take whatever old work box that I'm planning on using, and I'll take my wires and feed them into the box. Then once I've got them started into the box, I'll try and recess it into the wall some. That'll give me a little bit more slack with my wiring to pull them through some more. A lot of times I do need to use some needle nose pliers to pull them in the rest of the way because of how short they are. And then I'll use a screwdriver to tighten down each one of these screws. And what that does as I tighten these down on these old work boxes is it's clamping it to the wall. But currently the way that these are, they're still too short, not only to connect to each other, but they're also completely against code. I'll just demonstrate for you where I'm going to need to strip the insulation off of each one of my wires in here. Now that I've got those all stripped, now I need to make them longer, so I'm going to need to use some sort of a splicing device. In my opinion, the absolute best way of doing this is to use one of these right here. These are a Wago 221 inline connector. A lot of people don't know about this particular model, and some people don't even know what Wagos are. You can use wire nuts. I'll give that to you. You absolutely can. You don't have a whole lot of space as far as connection of wires to work with, so they're not my favorite. Whereas with these inlines, the way that they work really quickly is you just flip up a lever on each one of the sides. So now each one of the ports are open. I can then take one of those sides of the Wago, put it on one of my wires. Then once it's on that first wire, I just have to flip down the lever that's over it, and now that's locked into place. That's where then I'll now take a pigtail, which is basically just a long scrap piece of wire. You need your wires to be at least 6 inches long from the back of the box. So I'll take one end of that pigtail, put it into the other side of my inline connector, flip that down, and now as you can see, I've got a full length wire in this box to make whatever connections that I need to make at this point. In this case, a set of each, one set for the hots, one set for the neutrals, and one set for the ground wires. All right, so now all of my wires are lengthened and they're ready to be connected to whatever it is that we're going to be connecting. But again, in my case, I'm just going to be connecting them to each other. So I'm just going to match them up. And in order to connect them all together, this is again where you could use a wire nut, but in this case, I'm going to go ahead and use one of these other types of Wago 221 connectors. And this is a 2-port connector. They also have them in 3 and 5-port connectors. And now I'm just going to put each one of the leads of each pair of my wires into those Wago connectors. Obviously black hots with black hots, white neutrals with white neutrals, and bare ground wires with bare ground wires. And now that all those are connected, now all I need to do is place them in the back of the box. All right, so it's now at this point where I could just put a cover plate on this box or put some light switches in to kind of disguise it. I'm gonna leave that up to your imagination as to which way you would like to go with it. But at this point, all of my connections have been made. That Romex has now been repaired. Everything is connected again and in a safe manner to where this is gonna be completely contained in this box. And one thing to note, it does need to be accessible. You cannot just take one of these boxes and put them in the wall and then mud over it. By code and for very important troubleshooting and safety issues, this needs to be accessible, which is why we do this particular method. And by then just putting a cover over it or light switches, whatever it may be, you now do have a very safe and code compliant box that is accessible. And even though this is a mock-up wall, I do have power flowing through it. So before we made this repair, there was no power going from side to side to where this junction box was actually feeding across the wall to then my light switches. But as you can see now that we've made our connection, everything is done correctly and safely. If I flip on my switch, the light comes on, so we have a good connection there. But if you're looking for a way that you don't have to have an exposed box or anything like that, the next method will show you a legal way that you can go about doing that and a device that a lot of people don't realize even exists. All right, but let's say we're back to this place again. We've cut our exploratory hole, which this is pretty large for an exploratory hole. But let's say you're not wanting to replace this or put a box in this hole. You want to cover this back up with drywall and mud to make it look as though this never happened. Well, you can't just use wire nuts or even Wagos to make your connections, bury this in the wall, and then cover it up. Anytime you have splice points, they have to be contained somehow. But now there are certain splicing devices out there that are UL listed and are approved per code to be able to be used in order to just connect these wires together and then mud over it. And these have been seen or are seen more so in some of your mobile home applications, but they are allowed in your more traditional houses. And that is this device right here. This one in particular is made by NSI Industries, and this is basically a giant splicing device that, because everything is enclosed underneath of this clear plastic here in this housing, that it meets code. So I've taken that clear plastic housing off of it, and what we're going to need to do is we're going to need to take our wires and they're going to press into these terminal points here. But we are going to need to make some little measurements here. We got to cut our sheathing off down here where it's going to enter into this particular splicing device. So I'm going to go ahead and do that now for both of them. All right, so now I've got the sheathing cut away from both sets of wires. And here's kind of the crazy thing about this is we don't need to strip off any of the insulation for this particular splicing device. But the way that these work are these silver forks that you see. We're actually going to be pressing our wires into each one of those connection points. And when it does that, it's actually going to cut the insulation itself. And that metal then is going to be exposed and contacting the copper that's underneath of the insulation. So if we look at this really closely, you can see at each one of these terminals, there is a color written off to the side. So in this case, this says this is white, this is green, black, and red. So obviously white is for the neutral. Green would be for if your ground wire had green insulation on it, or if it's just the bare copper wire, that's where that goes. You have black and red. That's of course if you have two separate hot wires. If you're using like 14-3 or 12-3, that's where those two would go. So you want to make sure that everything lines up perfectly. With these, the hot wires are going to be a little bit longer than the neutral or ground wire are going to be. So you just have to cut those just slightly shorter. And then I just need to line each wire up with its designated terminal. And then once I've got those all lined up, I just need to take that clear plastic piece again and set it in on top of those wires while they're sitting in those designated terminal spots. And then once I've got that clear piece of plastic over each one of those wires, they're still in their correct spots. I want to push this clear plastic piece down onto the wires and it will lock into place. Now, this can be a little bit difficult to do by hand. So even the instructions say that you can use a pair of adjustable pliers like this and gently clamp them together. There are two screws that now need to get inserted into each side of that clear plastic, and this is going to make this install more secure and a little bit more permanent. All right, so now this side is completely connected and done. But with these types of devices, you actually have to install two of these, one on each set of wires, and then they clip together, kind of like a plug. So I'm just gonna push that back towards the back and just very quickly install the second one for you. And the second one is identical to installing the first one. All right, so now I've got my two plugs completely wired up. And for you guys to be able to see this a little bit better, I'm gonna go ahead and take this drywall down real quick. All right, so now that the drywall's out of the way, you can see this a little bit better. We have basically two plugs now. If we look at the ends of these, you're gonna see metal prongs all along the inside of both sets of plugs. And the way that these things plug together is one has to be the opposite direction of the other, and there's a clip on this side where they snap together at. So all you have to do then at this point, once everything is wired up like this, is just push those two sides together just like that. So both sides are locked in, and now this connection is completely made here. If we had our drywall still up here on the wall, this is where then you could take a drywall patch, put it on there, mud it all in, and then paint over it. And these are technically allowed per UL listing and code to be buried in a wall and don't have to be readily accessible. But some of you might be having a hard time with believing that just pressing those wires into those separate terminals, them cutting into them, that it's going to be able to carry the current to whatever it's going to next. So I'll demonstrate for you really quickly that now that this connection is made, that now that bulb will come on. All right, so again, our connection's made here. I'll go ahead and flip on the switch and that light bulb should turn on. So as you can see, while some people might have a hard time believing that those little pieces of metal cutting into that insulation are going to be able to do the job, again, they're UL listed, they've been tested, they've been used in some different scenarios over the years, and so these are approved to be used, and as you can clearly see, can make this repair, make that connection, and pass that current along. And for those of you that might still be doubting whether or not this is where the current is actually coming from to that bulb, I'll go ahead and disconnect these two plugs here, and you'll see the bulb go out. So just like that, disconnected them, the power quit going to the bulb and the bulb went out. If I go ahead and reconnect them together, as you can see, the bulb is back on. So these can in fact work. And just so y'all know, like always, for your convenience, I'm gonna have links for these connectors here and others like them. I'll also have links for all the other boxes and wire connectors like the Wagos. I'll have links for everything down in the description down below. So that way, whenever you click on those links, it will take you directly to whatever you clicked on. So you can easily locate and check out all of this stuff for yourself. All right, so for this next fix for fixing damaged wires, this is really gonna come in handy in places like your attic or your basement, your unfinished garage, anywhere especially that is just not finished. And that's gonna come down to this open splice box right here. But they can make your life a whole lot easier in those exposed areas. So the way this works is, of course, you find where your wires are damaged. We're gonna cut them at that damaged portion like we did earlier. So now we've got 2 sets of wires again. Then when it comes to this open splice box, what we can do is trim off the insulation so that we can make a connection between the wires, and we can use either wire nuts or the Wagos again. Then that's when we'll take our box, we'll center it with wherever our splice points are. We will take 2 screws and mount them in whatever way we can to some framing around where we've made our splices. Once the box is mounted in place and our wires will be able to sit clearly down into the middle of that box, that's when then we can fold down 2 pieces of plastic on either side of the box, lay our cabling down over those folded sections, and now push our splice points down into the open splice box. Once all of that is done and our wires are pushed down into the splice box, all we have to do then is close the lid. It will snap down into place using some plastic connectors that are built onto the box. Then we would take a screwdriver, and there are 2 screws on both sides of the box where we would tighten those down until they're down nice and tight. And now we have a very safe, accessible, and code compliant way to fix our damaged wires. And it's just as easy as you saw, and will probably only take a maximum of around 10 minutes to do. So now that I've shown you a few different methods on how you can go about fixing those damaged wires, I know I'm gonna get quite a few people asking what method I would go with personally. And for me personally, just going through each one individually, if we're talking about an open area, whether it's in an attic, down in a basement, maybe it's an unfinished garage, whatever it may be, you don't have a finished wall, then for me personally, I'm gonna probably go with the open splice box every single time. And the reason for that is it is just so easy to use, especially if you're in an attic. A lot of attics are very hot, so it's really a convenience thing for me. Nothing wrong with doing it the other way or the more old school method. That way works fantastic. So if you don't mind it taking a little bit longer, then by all means you can go that way and save a few bucks. If we're talking about how I would go about fixing damaged wires in a wall, for me personally, I am probably going to cut a hole in that wall, put in some sort of a junction box. If it's close enough to a light switch or a receptacle, I'm gonna try and disguise it that way by installing a light switch or receptacle. But if it's just in the middle of the wall, I'm just gonna put a blank faceplate over it, because to me, I think that that is probably the most reliable way of doing it. But there's nothing really wrong with using these types of devices that I showed you in this video where you can bury this in the wall. So it kind of is up to you. These are code compliant. You do want to make sure, again, that they are UL listed. But for me personally though, I'm personally probably not gonna use these unless I find myself in a pinch where I just need to. I need to make sure that wall just looks flush like it did before, and somewhere where a box would just look absolutely terrible. Now, I personally have never heard of these failing. Whether that's just due to they work perfectly and you don't have anything to worry about, I'm not sure. Or is it more so most people don't know about these and they're not used very widely? I don't have the answer to that, but it's totally up to you, and I'd actually be curious to hear which way you would go about doing it. If you could leave me a comment down in the comment section. I always like reading those comments and getting other people's opinions and experiences. And regardless of which way you would go about doing it, for your convenience, I will have links for everything you saw in this video, from those different splicing devices to the open splice box, the regular boxes, and all the tools that I use. I'll have links for everything you saw down in the description down below. So when you click on those links, it will take you directly to whatever you clicked on, so you you can check it all out for yourself. Now, really quickly, if you found value in this video, then you will definitely find value in some other videos that I've done in the past where I go over some very common and dangerous electrical mistakes. In those videos, I talk about what those common mistakes are, and then I also talk about how they should be properly done in order to provide a long-lasting and safe connection. So definitely recommend taking a look at those if you haven't already. So I'll post 2 of those videos right over here. Whichever one interests you the most, all you have to do is click on it and it will take you directly to it. But I hope that you found value in this video, and if you did, if you could do me a huge favor, hit that thumbs up button right down below. And of course, if you have any questions or comments still, you can leave those down in the comment section. And I'll catch you all in that next one.